All right, so welcome to the first lesson of the Minor Math Jumpstart. In this section, as you can see, we're going to be looking at linear equations. We're going to go over 15 lessons. Some are longer, some are shorter. This is actually, I believe it's the longest one. With that said, they're not too long. If you do find it to be a bit long, you can pause the video, take a break, and then continue along. If you feel like taking notes, you can take notes. You can print them out. You should have a printed out packet. So, without further ado, let's get started. So, like I said, we'll be looking over linear equations here. So, a linear equation. What is a linear equation? It's an equation of the form y equals mx plus b. We probably recognize this from high school math, high school algebra. And the y equals mx plus b, well, what does that mean? Those are just letters, right? So in this case, y represents the dependent variable, meaning it depends on whatever x is, right? That's what dependent means. If you remember, m represents the slope. X in this case is the independent variable. And finally, b is the y-intercept. And we'll go over what this means, the y-intercept. What does that mean? Let's take a look at these three lines. We have a red line, a green line, and a blue line, right? And all these lines can be represented with a linear equation, right? Here in red, we have y equals 2x plus 3. That represents that line there. In blue, we have 2x plus 1. And in green, we have 4x plus 2. Now, the y-intercept, what that means is where it basically boils down to where it crosses the y-axis. So if you notice this equation in red right here, we have a b of 3 or a y-intercept of 3. And all that means is that at y equals 3 is where our red line crosses the y-axis. That's all that is. So notice the one in green over here, we have a slope of 4. We have 4 for the m. So it's a lot steeper than the red one and the blue line. So we can go ahead and play with these equations. We can see how to manipulate them, how they change. Notice any patterns. But it all just boils down to those 4 variables which help represent linear equations. Now, there is something also known as a standard form. You might see a linear equation as ax plus by equals c with a few restrictions, where a and b are not 0 and a is greater than 0. Now, I don't have an example, but I'll just go ahead and write one here. Let's say a is 4x plus 3y equals 8, right? So that's still a linear equation. It does not fit in the form y equals mx plus b because it's of the form ax plus by equals c. In other words, it's in standard form. Now, can we make it look like y equals mx plus b? Absolutely, right? They're both lines. So we can make them look, we can transform one to the other. All right, so after this, we have finding the x-intercept. Now, how do we find the x-intercept? First of all, just like the y-intercept, b was y-intercept, x-intercept now means when does it cross the x-axis, right? And there's a lot of words for x-intercept. Before we continue, not only do we hear x-intercept, you might hear the word roots or solutions, or maybe even zeros. Those all mean x-intercept. But to find the x-intercept of a linear equation, we're going to set y equals to 0 in the equation. Solve for x. And then our y-intercept will be the point x comma 0, right? And x is a value found in step 2. But what use is this if we don't have an example? So let's go ahead and go over an example, and then we'll follow along the steps, right? Let's not get too intimidated. So the example's telling us to find the x-intercept of the equation y equals 2x minus 6. Well, using the steps, let's go over this. So first of all, like it's telling us up here, set y equal to 0. So we're going to go ahead and set y equal to 0. So we have 0 equals 2x minus 6. What's the next step? Well, step 2 tells us solve for x. So we're going to do some algebra here. We'll add 6 to both sides to get rid of that minus 6. So those two will cancel. And we'll have that 6 is equal to 2x. Now, x isn't by itself just yet. All right, there's still a coefficient of 2. But what we can do is divide both sides by 2 so that those 2's cancel out. 6 divided by 2 is 3, so we get 3 is equal to x. And that's our x-intercept. Right, so as step 3 says, x is equal to 3, so our intercept will be x comma 0. In other words, 3 comma 0. Pretty straightforward. Reading the steps just themselves is a bit too much information until you see an example, and it becomes much more straightforward. So now let's go over the y-intercept. How do we find the y-intercept? Pretty much the same steps, right? We're going to set x equal to 0 now in this equation instead of y. And then we're going to solve for y. And finally, just like the other third step, our y-intercept will be 0 comma y. And like we did before, we're going to go over an example. Here they're asking us to find the x-intercept. That is a typo. That should be the y-intercept. Y-intercept of the equation y equals 2x minus 6. So how do we do this? We're going to set x equal to 0. So notice that instead of x there, we have a 0. And 2 times 0 is just 0, so I'm going to cross that out. What does that give us? Well, simply that y is equal to negative 6. All right, now that we have y, we know that our y-intercept is 0 comma negative 6. So we got our x-intercept and our y-intercept of the same linear equation. And these steps are in your notes. We can't get better if we don't practice. So it's just a matter of practice before, this becomes second nature. All right. If you look at this picture here, we have the y-intercept there of 0, negative 6. And actually, I skipped that picture there, but if you go back in the video, you'll be able to see that we have our y-intercept and our x-intercept. Got a little ahead there. But we're going to be looking at slope now. Again, you've probably heard about slope in your pretty much every class, algebra, geometry, all the classes you took in high school as far as math goes. You probably heard about slope. For slope, we have 4 different types. We have an uphill one, which is a positive slope, downhill, horizontal, and vertical. And it tells you what kind of slope there are. If it's going upwards, it's a positive slope. If it's going down, negative. And as you can see, if it's just horizontal, the slope is 0. And careful with this one, the vertical one. Vertical does not mean slope 0, it means undefined, meaning we don't have a slope. But how do we find slope? We use the equation m, because m represents slope, equals y2 minus y1 over x2 minus x1. Again, that might be ringing a few bells. So using this equation, and again, let's go over an example to see how this works. Say, for example, we're asked to find the slope of the line y equals 2x minus 6. Now, if they provide a line for us, and as a matter of fact, this is the line from the slide before, we can choose any 2 points on the line. In this case, I'll point out the little points here, 0, -6, and 2, -2. Right? Any 2 points on the line will work. I just chose these to work with. So I'm going to label 0, -6 as x1, y1, and 2, -2 I'll label as x2, y2. Now, can we label instead 0, -6 as x2, y2, and 2, -2 as x1, y1? Absolutely. It doesn't matter which ones you label, as long as you just label 2 points. All right, it'll work either way. But now we can use our formula. So we have m equals -2 minus -6 over 2 minus 0. Now it's just a little computation, a little simplifying to figure out what our slope is. -2 minus -6 becomes -2 plus 6, and 2 minus 0 is just 2. Again, simplifying a bit more, -2 plus 6 is 4. So we have 4 over 2, and 4 divided by 2 is just 2. So our slope of this line, the slope of this line is 2. All right. And as you can see that 2 there, well, we can see the slope is 2 just by looking at the equation, right? But if they had just given us a line, we would have to figure it out for ourselves, and we just did. Okay, so here, to find the equation of a line, when, say, for example, they only give you points and the slope, then we use the equation y minus y1 equals m times x minus x1. Again, might ring a few bells. And this is to find the equation of a line, not just a slope. Oh, that was a bit messy. To find the equation of a line. So we use this formula. And again, example, we're going to find the equation of a line that passes through the points -4, 2, and whose slope is 5. So they're giving us a point and the slope of the line. All we got to do is find the equation of the line. So we should, first of all, label our points. x1 is -4, right? It's given over here. So -4 is x1. As you can imagine, y1 will be 2. And they're telling us that the slope is 5. So m is 5. Now, all we got to do is use our equation here. Plug in those little numbers, y minus 2. I didn't color code this number, but this was y1. Y minus 2 equals m times x minus -4. Right, so all we did was plug in those values on our left-hand side to our equation. And from here on out, it's just simplifying. So here, x minus -4 becomes x plus 4. That's the only thing that changes. Next, we can distribute the 5. So in this case, 5 times x is 5x. 5 times 4 is 20. And the last step is getting rid of this -2 right here. So what we're going to do is add 2 to both sides. These two cancel. And we're left with y equals 5x plus 22. Okay, now, all right, so last thing to look at is when we have lines, we can look at parallel lines. What about parallel lines? Well, parallel lines have the same slope. If two lines are parallel, meaning they never touch, they have the same slope. So again, an example, find the equation of a line that is parallel to y equals 4x plus 2 and passes through the points 2, 7. All right, so in this case, we can label again x1 as 2, y1 as 7, and from our equation here, we have m equals 4. Okay, so what do? Same as the slide from before. We use our same equation, y minus y1 equals m times x minus x1. All right, so after we have our equation, we already have x1, y1, and m. We know what they are. So we can just plug those in. Again, as we did in the previous slide. We'll plug those in. And again, it's just simplifying from here on out. We'll have that 4 times x is 4x. 4 times negative 2 is negative 8. So we'll have y minus 7 equals 4x minus 8. And all we got to do is get rid of this negative 7. So we're going to go ahead and add 7 to both sides. So those two will cancel out. And we end up with y equals 4x minus 1. So notice 4x minus 1 is not the same equation as 4x plus 2 because they are parallel lines. And what is that going to look like? That's going to look like this. Right, so we have two lines that will never touch because they're parallel. And the reason they're parallel is, again, because the lines have the same slope. All right, so we looked at parallel lines. Now what about perpendicular lines? These are lines that cross to make 90-degree angle, 490-degree angles. And my drawing is a poor one. But perpendicular lines have a negative reciprocal slopes. Now, what does that even mean? A negative reciprocal, what that means is, well, let's go over the example and I can show you. Now this problem is telling us find the equation of a line that is perpendicular to the line y equals 4x plus 2 and that passes through the point 2, 7. Again, if you're just to read this problem or the question, we're deer in headlights, right? But again, if we take it step by step, just as we did last one, we might get somewhere. So let's see. First off, we have our points x1, y1, be 2 and 7. But now we're not going to have the same slope. So m is not going to equal 4 here because our slope here is 4, but well, these are perpendicular lines. So what we're going to need is a negative reciprocal of 4. So 4 is the same thing as 4 over 1. What a reciprocal is you flip the 2. So the 1 goes on top and the 4 goes on the bottom. And let's not forget the negative, so we'll have a negative 1 over 4. So that's going to be our slope there. That's what perpendicular lines have. So I'm going to erase this to make space. So we'll get y minus y1 equals m times x minus x1. X minus, yes, x1. Okay. Now we're just plugging in. Again, we have the same information. Y minus 7 equals negative 1 over 4 times x minus 2. And again, just a matter of simplifying, we'll distribute negative 1/4 times x is negative x over 4. And negative 1/4 times negative 2 is positive 2. Oh, sorry, positive 1/2. And our last step here, just like in the last one, we're just going to add 7 to both sides. So plus 7 plus 7. 1/2 plus 7 will give us 15/2. So our perpendicular line will be y equals negative x over 4 plus 15/2. And again, what does that look like? That looks like this. So our red line is our original equation. Now our blue line is this equation right here. Y equals negative x over 4 plus 15/2. Now those lines are perpendicular. All right. If you have any questions, go ahead and ask. You guys do have problems you guys can work on to practice these concepts. It's a lot to take in at once, especially if it's been a while since you took algebra. So with that said, just practice, try to, you know, have these concepts in your head so that they become second nature.